Um, yeah. Okay, so welcome to Category 1 workshop. Category 1 covers Ping Pong Parachute, Wright Stuff, Boomilever, Gravity Vehicle, and Machines. So at the end of this presentation, we're going to have a Q&A session. So if you have any questions while you're presenting, just type it out in the chat. We're going to start with Ping Pong Parachute and we'll end with machines. I will present Ping Pong Parachute and Wright Stuff. Tracy will present Boomilever and Gravity Vehicle, and Angelica will present Machines. And all these events are build events, except Machines also has a written test attached to it. So Ping Pong Parachute. So in Ping Pong Parachute, you're supposed to build a rocket and a parachute, and you're basically judged based on how long your parachute stays in the air. The highest flight wins the first position, and so on. So some of the event details and things you should know are that you cannot hit the ceiling. So if you hit the ceiling, you get points. They cut points, they deduct points, and then you must use a carbonated bottle and you must leave the label. These are two of the mistakes we made in the past. So make sure you don't do that. Make sure you have the label and make sure you're using carbonated bottle because they're the ones that can take the pressure. Regular water ones cannot take that pressure. And use tape to attach the fins and ping pong ball. Do not use glue. It's mentioned in the rule book and it's clearly said to not use them. And you definitely need to know the PSI. You need to run some trials and figure out which PSI you should launch it at to to go get the highest time and get the highest point. And also here for the PSI, it's gonna vary from rocket to rocket because it also depends on the weight of your rocket. So yes, you need to do lots of trials for that. And then you also need to present a practice log. If you don't have a practice log, they don't let you launch your rocket. So make sure you have that. It is specified in the rulebook that you must have 3 parameters and then 2 additional parameters of your choice. And then you also get only 5 minutes to make 2 launches. Okay. So for the tryouts, the things you need to know. So you need to know the different tiers. So it is set in the rulebook and I'm gonna say it right now again. So tier number 1 is when you perfectly launch the rocket, it doesn't hit the ceiling, the rocket and parachute is detached and everything's perfectly fine. Then tier number 2 is when you launch the rocket, but the parachute doesn't come off. So that's tier number 2. And tier number 3 is when you hit the ceiling. So make sure you know there are differences and you might be given videos and you might be asked what number tier is this? And then know the parameters of the rocket. So there are some conditions you need to meet how that you need to use a 1 liter bottle or then the other one, the most important one is your fins need to be 5 centimeters above the mouth of the bottle and you'll see a picture of it in the next slide. And then, of course, the 3 required parameters for the log. The 3 required ones are the PSI, height, and the time. And you need to have 10 trials in your log. And for the for the trials, you also need to know or come up with your own diagram or your own design of the ping pong parachute and the rocket. And then also estimate PSI. So we're probably going to give you a condition and we're going to say, okay, this is the weight, this is the height of the room, this is the PSI they're using. So what is the PSI going to be if we increase the height, but we keep the weight of the rocket the same? So some small math related questions, and then we will ask you to answer situation-based questions. So for example, you went to the testing room and you didn't bring your goggles. So what do we do now? What do I do now? So it's just we are going to check whether you're able to come up with a solution at the heat of the moment and make quick decisions. And then also we're going to test on some science concepts about force of gravity and air resistance. Jimmy, would you like to add on to that and talk about it?
I muted, sorry. So one other thing I remember was the I don't know, the top of the rocket or whatever it's called. It needs to be like smooth. It can't have any like jutted edges. So like a normal rocket's really pointy. So what we recommend is to put the ping pong ball like as a capsule. So if you imagine an actual rocket like SpaceX or something, the capsule comes off. So when you launch the rocket, the ping pong ball is already smoothed out. So it's like the capsule of the rocket, and then it just comes off at the peak. And so that's what we recommend. But if you do find different strategies for the rocket, then by all means go ahead. Force of gravity. This one's a little general, but I'd say the material you use for the what is it called, parachute, when it comes off, you want to find the perfect radius. So if it's too big, the parachute would be too heavy. So that's counterproductive. And if it's too small, there's not enough air resistance under I don't really know the exact physics, but something like air resistance under the parachute won't be enough. So you have to find the perfect radius. The shape should either be a circle or a hexagon kind of deal where you connect strings to the ping pong ball. Yeah, that's all I got. I don't know the exact physics, so I'm not gonna try to make myself understand.
That's okay. Ayush, would you want to add something? You did it too last year.
I think you guys have covered everything, so I don't have much to add.
Okay, thanks. Okay. So this is what I was talking about, like the cross. This is what Jimmy talked about it needs to be blonde. And then this is what I mentioned, it needs to be, the fins need to be 5 centimeter above the mouth. And then this is just a regular one. If you use a 1 liter bottle, this is gonna be there. So you don't have to worry about this one. And then here I found some pictures, and this is just some examples of types of parachutes you can have. And then here is the rocket. So you can actually make the rocket, I mean, I have seen 2 different ways. So you can have that too, or like, I think you call it missile, I'm not sure. And you can have that, or you can also have you can also have your rocket without that. So it just helps you, if you have it, it just helps you, I think, raise take it to the max height. And yeah, so it's just, again, try some trials, and just see which one works the best with your PSI, with what you have got around you. So yes, and I also have some videos of us launching and practicing, so I'll show it here. Second. Okay. So this is okay.
Let go! Let go! That's really good.
Oh, okay.
All right, $10?
Three, two, one.
It's not pressing zero. Sorry. Oh, there you go. All right, you boys. 2, 1.
That's it. Okay, so at this point, if you have any questions related to ping pong parachute, please type it out in the chat. I'll address them at the end of the presentation. And okay, now, well, so now off to Wright Stuff. Wright Stuff is the same deal, kind of. So you just have to keep it in the air for the maximum amount of time, and that's how you're judged. And in my opinion, Wright Stuff is one of the more technical ones. So you have to run lots and lots of trials, fly it a bunch of times, fix and trim a lot. So this is one of the time-consuming build events, in my opinion. So some of the details during you need to know, or like what goes down during the competition, is you get 3 minutes of prep time. So you do whatever you gotta do in the 3 minutes. You get to trim, you get to adjust, and do everything within that 3 minute time frame. After that, you don't get to do any modifications. Then you get 8 minutes to make your to launch. I mean, to release your planes, and you can have 2 flights in total. And then again, you need a log. They will let you launch. I mean, they will let you fly the plane without a log, but they'll take off points. I'll talk about it more in the next slide. And then another condition you need to meet is that the plane needs to make a 360 horizontal turn at least once. And then you can bring 1 or 2 planes depending on how many you make, and then using 1 plane for 2 flights. So okay, here they also give like a bonus point, kind of. So let's say you bring 1 plane and you're using the plane to wait, hold on a second, something's cool. Okay, so you have 1 plane and you're gonna release it once, and let's say it goes up in the air in a clockwise circle. Once it comes down, you can release it again, but this time it needs to go in a counterclockwise direction. So if you can do both the counterclockwise and clockwise rotation with 1 plane, they add up the 2 flights together and you get a final score. However, if you used 2 planes to run 2 different flights, they would just keep the highest time you get. So 1 plane, so if you know how to adjust your plane in like a minute or so and run 2 flights at once with that same plane, counterclockwise and clockwise, you almost like can say that you're gonna be in top 3. So yes, it's like a special case. And then make sure you always bring your own winder, because if you don't bring your winder, you will not be able to wind the motor or like the rubber. And yes, and that might cause some problems, because you want to get the maximum or the number of winds you want. So if you don't have a winder and you want to do it by your hand, then it's gonna take away all your time. Oh, okay, so for the test, for the tryouts, so we need you to know about the log, what the parameters you need to have, so 3 required and 3 additional ones. And then, so if you bring an incomplete log, you get 10% of your time deducted. And if you don't present a log at all, you get 30% of your time deducted. Once again, know the parameters of your plane. There are some conditions, like the wing needs to be 30 centimeter long, and there are like some conditions. So I would say, or the thing we did last time was that we used a kit, so we don't have to think about like getting the parameters right, because it was already given to us. And then you can also earn a bonus point. So I want you to look through the rulebook to find that, because it is clearly mentioned in the rulebook. I don't have to say it here. And then you can also earn a bonus point during the prep time. So for example, you know how you're giving 3 minutes for your preparations. So if you finish before the 3 minutes is over, you get bonus points for that. And then you need to know Newton's third law, like how it is working on the plane. So here, for an example, the propeller, if you are looking at it from the front, you'll see the propeller, it rotates in a counterclockwise direction. On the other hand, the body of the plane, it wants to rotate in a clockwise direction because of the motor, like the rubber band. So this is just an example. So what opposite reactions here. So this is how Newton's third law is working here. And then know some examples of asymmetric constructions, because to make your plane perfect and make it stay in the air, everything's not going to be straight. So for example, the propeller, it's not going to be straight. It's going to be 2 degrees off, and then the wing needs to be like 10% more on one of the sides. So yes, you also have to do lots of trials to see which one works the best, and yeah, lots of trials. And then know the major parts of a plane and also their functions. So their wing assembly, motor, horizontal stabilizer, vertical stabilizer, and you'll find the other two in the research packet. It's clearly mentioned there. And then what causes the plane to fly in circles? There are multiple factors that play a role in here, but one of them, for example, would be if you need to bank one of the sides of the wing. So the direction you bank the wing, that's the direction your plane is gonna turn. So if you like bank it towards your left, it's gonna go counterclockwise. So yeah. And then finally, what causes the plane to mount? It is clearly mentioned in the research packet. So I want you to look and read through it, and you will find the answer there. And then be able to answer situation-based questions, like just like ping pong parachute. If something, the motor, the rubber just breaks, you need to be able to answer what you need to do immediately, think promptly, and yeah. And then this was our plane. I didn't have any other picture other than this. So we used the kit. So in here, this is the vertical stabilizer, and then this is the horizontal stabilizer. This is the body, and this is the motor, this is the propeller, and this is the wing. And I didn't have a video of our flight, but I found a video, so why not? Okay. Once again, if you have any questions, please type it in the chat. I'm gonna address it at the end. Tracy?
Yes, so next we have Boomilever. So Boomilever is a build event where you build a wooden structure that connects to a wall at one point, and it has to hold a specific weight. So there'll be like a bucket, and you'll have to like pour sand into it, and it'll have to hold like the most amount. So event details, to win, you want to hold the most amount of sand, and you want your structure to weigh the least. So that's structural efficiency. So it'll be calculated by dividing how much your Boomilever can hold by how much it weighs. And then while you test, you'll have 6 minutes to set up and test your structure, and then they'll record it. And then you also must have eye protection on the day of the competition. If you don't have eye protection, you'll be considered DQ'd and you won't be able to test your structure. So the eye protection has to be level B. And when you build your Boomilever, it has to be made up of only wood and adhesives. So make sure while you build it, you follow the construction parameters, which you can find in the Science Olympiad rulebook. And also make sure you know the building policy, which is basically to like show that you built this on your own without like stealing ideas or like having help from outside sources. And you can also find this in our resource packet and also the Science Olympiad website. And then next will be what you need to know for tryouts and some tips. So for what you need to know for the tryout test is that there are some basic types and designs of Boomilever. So two of the basic types are tension and compression. And then you have to make sure you understand how this works and what tension and compression is. Also know the different like basic designs like a normal Boomilever, tower chimney, box beam, and compression tube. And also like know the parts of it, be able to like label if it's like the tension or compression or like the different parts of it. And of course, like these are just some basic designs. You don't have to like build your Boomilever based off of this. You can also experiment around and build something that's not off of this. And then also in our packet, we have a table of key terms that you should also know, which will help you like understand the parts of the Boomilever and also like understand the different joints, which will basically help you make your Boomilever stronger. And this is also listed in the packet, and you can search up pictures online to get a better visual representation. Also, while you read through the packet, have an idea of possible materials that you can use and why, because it'll make it easier for you to plan out like a simple sketch of a design and like be able to describe it. And also it'll make it a lot easier and cheaper for you when you start to build. And like most people tend to use like CA glue, or they use like Gorilla Glue, or they use a specific type of wood that will help make the structure light, but it's also strong. So this will help you sketch out a simple design, which you will also have to be able to do on the test, so that we know that you have understanding of what a Boomilever looks like. And also make sure you know the parameters that are required for the competition day. So like the distance the loading block has to be from the wall, and the maximum vertical distance and the minimum horizontal distance that your Boomilever has to be, so that it doesn't enter like the gray zone and you get like points taken off for that. And then next we have like a few pictures of Boomilevers. The top left-hand corner is what a tension Boomilever will look like, and as you can see, is attached to the wall by a J-bolt, which is basically a hook, and then on top of it is the loading block, and then below that picture is basically a simple example of another tension Boomilever, and it has like little parts labeled. You can also find this in our packet, and you also need to know what those parts are for the tryouts test. And then the picture on the right is just like different examples of Boomilevers that people have done in the past. And then we also have a few video links for you guys to watch. So the first one shows a compression Boomilever, and it basically is like a failed one where it breaks.
Oh, it wasn't centered in the bucket. Oh, no.
And then the second one we have is another example of a Boomilever, and it's instead of using sand, he used water, but on the competition day, you'll be using sand. So that's about it for Boomilever. You can find more information in our resource packet. And then next we have gravity vehicle. So gravity vehicle is where you build a ramp and a vehicle that is powered solely by its gravitational potential energy. So for this event, to win, there's a set target distance, and you want to arrive there at the most fast and also the most accurate. So speed and accuracy are the main ways that this event is scored. And you'll have 8 minutes to do 2 runs, and you can adjust in between. So you can adjust your ramp, or you can adjust your vehicle while you do this. And while you adjust, they'll remeasure it, and you won't have time taken off when they measure that. So you don't have to worry about losing time if you like adjust your ramp and they measure it again. Also for this event, you also have to fill out a practice log. So for the practice log, you'll have to do 10 runs and you would have to record 4 parameters, 3 required ones, which is your target distance, the vehicle distance, and then the run time, and then 1 additional parameter of your choice. So it could be like the axle turning or like just anything that you can record. For this one again, and like for all build events, make sure you know the building policy. And then for gravity vehicle, they also provide you with a track. So the track will be something smooth and leveled and hard. And most people like to bring cleaning, so like a rag or like a broom, so they can like clean the track off before they use it, because sometimes there is like dust or maybe dirt on the track, so you don't want that to affect your vehicle and like cause like traction or like slow it down and that stuff. So it's recommended to bring something to clean your track off. And no, you cannot wet the track. The track has to stay dry. So just bring something to clean it so that you clear your track out. And then next is some stuff that you'll need to know for the tryouts and like little tips. So in our packet, we have a picture of a diagram of like the vehicle and also some what makes up the vehicle. So make sure you know and understand what makes up the vehicle, including the braking system. So there are 2 types of braking system. There's a string type, and then there's a threaded rod type. These are just like basic ones. You don't have to use these, but it's what's commonly used for competitions. Also, make sure you understand what gravitational potential energy is and the difference from potential energy, and then understand the role of kinetic energy and how friction affects your vehicle. Again, like all the other build events, make sure you're able to create like a rough draft or like a design of a gravity vehicle and like your ramp, and like include like a description so that we can understand that you know what the gravity vehicle looks like and like the parts that make up the gravity vehicle. Also think about different possible materials that you can use and like why as you create a rough draft, because again, it'll make it a lot easier for you to have a cheaper, it'll make it a lot easier and more efficient, and also it'll be a lot cheaper instead of just going out and buying random things. And so this will also be really helpful. And like some people like to use like a specific material for their ramps because they don't want it to be too flimsy and they don't want it to be too slick so that it causes your vehicle to slip, and also they don't want it to cause a drag. So it's important to do your research ahead of time. Also, make sure you read and know the parameters, especially for all build events, because if you do build it wrong and have the wrong measurement, you could be disqualified or you could lose points. So make sure you know the parameters and like the requirements. And for a gravity vehicle, the ramp and the vehicle has to fit into a specific box. So make sure you read up on that and know it, and also understand how scoring is calculated, the tiers, and like penalties. So for scoring, it'll be you'll multiply 2 points by the distance and then 1 point by the runtime, and then you add any penalties that you have. And so, Ayush, I know you did this event. Do you have anything to add to Gravity Vehicle?
Yeah, I would focus more on getting your vehicle accurate before getting it fast, because accuracy is probably the most important thing, and they use speed as like a tiebreaker. And also for your first ramp, like it doesn't have to be really pretty, because when we went to Rice, the team's ramp didn't look too great, but they did pretty well. So don't be discouraged if you can't get like a perfect looking ramp compared to other teams.
Okay, thank you. And then on the next slide, we have a few pictures of what the gravity vehicle and the ramp looks like. As you can see on the left side, you have to use an unsharpened number 2 pencil to release your gravity. And then on the left side are just some basic designs of a gravity vehicle. The top one is with a string type braking system, and the bottom one is with a threaded rod type braking system. And then we have a little YouTube video links that demonstrates what the gravity vehicle will look like on the day of competition.
Like you get fussy. Your resent right there. My dirty shoe. There you go, last one.
Tracy.
And then, do you want to play the second video link too?
3, 2, 1, go.
Ooh, nice.
Okay, and then next we have machines.
Angelica.
All right, so machines, unlike the other events we've talked about today, actually has both a build portion and a written portion to it, meaning you both have to build a device and you have to study for a test that you will take on site at the tournament. Let's start with the device. So in machines, you have to build a first class lever, which is connected to a series of class 2 and 3 levers that will measure the masses of 3 unknown objects, which will allow you to find the ratios between 3 unknown masses. Okay, let me break that down for you. So starting with the lever, there are 3 different types of or classes of levers, which you'll learn about in physics, but in the next 2 slides I have a picture that will show you the difference between a first class lever and a second and third class lever. Basically, you have to build this lever, and you need to be able to measure the masses of 3 objects that will be given to you on site at the tournament. And you do that by adjusting the mass on your lever, and then according to the numbers on the lever, you can calculate the ratios between these 3 objects. And that's the goal at the tournament. You have to find the ratio of the 3 objects. So when you're building the device, you can actually use any type of material you like. And the only restriction is that you can't include springs, because that would give you an advantage to others. You also need to include a graph or a table, and as well as a labeled device diagram. Because the way machines is scored is that you're not only scored about how well you build the device or how well you do on the test, but you're also scored on whether you have this graph or table or labeled device diagram. They add up all these different components, and if you do a device or a labeled device diagram, or if you include a graph and table, you get more points, and the more points you have, the higher ranked you are. So that's why we want you guys to also include these 2 components when you're preparing for machines this year. When you're at the tournament, you are given 4 minutes to find the ratio of these masses. And again, you do that by adjusting them on your lever. And the thing is, with machines, you also are scored on how fast you can find the ratio of these masses. So if you can do it before 4 minutes, you will have an advantage. And finally, regarding the written test will go over some basic concepts in physics related to machines, like IMA, or actual mechanical advantage. And then it's a 20-minute written test, so you get 20 minutes to take the test, and you must include metric units and the proper number of sig figs. So if you've taken chemistry, you know what sig figs are. It's basically the number of digits after the decimal points. It depends on the numbers given to you in the problem. And if you don't include metric units or sig figs, you might get the whole question wrong. So this is very important to note. And note that on the child's test, we might ask you this. So please make sure you emphasize, take more emphasis on these points on the slide. Okay. Continuing on, here's what you need to know and some tips you're going to need to know for machines both on the tryouts test and in general. First of all, just like Tracy said before, in gravity vehicle and Boomilever, you need to know the device parameters for machines and what materials you need. And you can find this on the rule book, and it'll also be on a resource packet for category 1. You also need to be able to sketch your device or explain what you plan to do on the test, just like every other build event in this category. So please make sure you do some personal research for machines. Maybe search up some videos or some pictures and look through our packet so you know how to sketch it. Regarding the written test, you're going to need to know F equals MA as the basics for all physics categories. You're going to need to know that formula for the tryouts test especially. And for our tryouts test specifically, you're going to need to know ideal and actual mechanical advantage and efficiency and how to calculate them. We have explained this in our packet, so please refer to that. On the actual written test during the tournaments, they will ask you for more calculations, but we're just shortening it for you on the tryouts test. So make sure you do look at the rule book, both for tryouts and in general throughout this year. Also, you need to be familiar with the following compound machines, which is a gear system, differential pulley, and windlass. And there are actually a lot of compound machines you might need to know, but these are the two we're going to test you on. 3 we're going to test you on. And some simple machines you also need to know: inclined planes, screws, levers of all 3 classes, and wheel and axle. And you might be wondering, well, how can I be tested on a screw? But there's a science behind a screw. There's a science behind inclined planes, and the machine's written test will ask you for that science. It might ask you to solve for the IMA of a inclined plane, or it might give you some numbers or like a formula to make the lines on the screw. You might need to solve for that. Again, this is given on a resource packet, but in the future, you will need to know more simple machines. So machines is basically exactly what it sounds like. It's about machines. So if that's something that interests you, this is a good event to pursue in. And on the next slide, I have put a picture of a first, second, and third class lever, as well as a picture of a lever that has been used in Sayuli before. And the thing to know is, well, actually, actually, Siddhant, I know you've done machines, so would you like to explain more about this diagram right here on the left, or anything in general about machines?
So for the machine that I used, which would be like the right one, the top lever is it's the first class lever because the fulcrum is in the middle, and the bottom lever would be signified as a second class, since the effort is on the leftmost side because of the string and it's pulling it up. And so basically you put 1 mass on the right side for the first class lever, and what I did was I put the second mass, or the heavier mass, at the bottom, right, like between the string and the fulcrum of the second class lever. And to find the ratio, you just measure the distance between the fulcrum and where like the mass, it's like it gets leveled. And since it's based on torque, since it's based on torque and torque is equal to RF, which is the equation that you learned in physics 1, it's easier to find the ratio just from that.
Okay, yeah, so one thing you need to know about machines is that there is some math you're going to need to know. And this is on the SciOE Wiki website, the torque he was talking about, and the fulcrum. This is all explained on the website as well as in our research packet. And in this diagram on the left, where it explains the first, second, and third class levers, this is what Siddhant's talking about. For example, if the first class lever has the effort on the left, second class lever has the load on the right, the third class has it on the very right, the load on the very right, and the effort on the very left. So there's a difference. There's a difference between all these three levers and types of levers, and you need to know these differences. It's really important. So that's why we're testing you on IMA, especially because they will ask this many times. I've also included a YouTube link where you can watch. Someone is trying to calculate some masses with his lever in this video. Mario.
As you can see. So the goal of this is you want to try and get it so you want to move these masses so that these two rulers are level. To do that, you have to slide these masses around, okay? Now ours, this isn't actually level, but I've found that when it's at this angle, it does the best, but that's not gonna work for you guys, so you just wanna get it level. What you're gonna wanna do is, you wanna move this out and move that one out. Get it level as possible, and then you're gonna count these tick marks here. I have it marked on both of them. So this one is B, so this would be 75, and this would be 58. Then you come over here, plug in your mass ratio, so A over B, 75 over 58 equals 1.29. That's your mass ratio. The actual ratio is 1.28. So that's pretty good if you ask me.
Great. So that is machines. And if you have any questions, please feel free to put them in the chat and we can answer them.
Anybody any questions? You can ask us now.
Any questions about the events or maybe the resource packet in general? We can help you out with that, or anything about what we'll test you on in tryouts.
Anything?
Okay.
Just a quick reminder, our tryouts is on September the 5th, and yes, don't worry, you'll be fine. Sorry, are you gonna say something?
Yeah, okay. One person has a question. Do we have to try out for all the categories within category 1? Yes. So the reason why we've categorized these events is because we want to see what your skill sets are. Each category has a specific topic, and category 1's topic is building. All of the events in category 1 have to do with builds, and we want to test on all of the events in category 1 because we want to see whether you'd be better at building this device or this device. If we let you guys pick, we might not know whether you'd be good at gravity vehicle versus Boomilever, since it's basically the same skill sets. So yes, you do need to try out for all of the events in category 1. And in the resource packet, we simplified everything so that you don't feel overwhelmed when trying to try out for all these different events. So, without these packets, you might feel like, wow, I don't want to study for both Boomilever and gravity vehicle. Like that's a lot of information. Always specified it for you so it's easier. If that makes sense. Okay. Marty, would you like to add anything? Add anything?
No, I think you covered everything we had to cover. So yes, we're good.
Okay. Any other questions?
No. Okay, then I'll move forward. So to remind you again, our tryout is on September the 5th, and don't stress, you'll be fine. Just study 20 minutes every day. Like, it's not too much of studying, so you will be fine. And if you want to look back on this presentation will be posted on our website, and this meeting will be posted on our YouTube channel, so within 24 hours. So if you want to reference back to it, just go to our website or the YouTube channel. So yes, thank you everyone for
Thanks for coming. If you have any questions, text us.